Okay, so here we have got two experiments. One experiment is the first experiment I can write, that is your a fair coin is tossed. A fair coin is tossed. So for that experiment one, the sample space S1 I can write, that is head and tail. And the experiment two, that is an unbiased die is tossed, or an unbiased die is thrown. Unbiased die is thrown. So for that, the sample space S2, I can write it as 1, 2, 3, 4, 5, and 6. So here we have the combination of these two experiments. So the event A has been defined as head appears in the coin. So therefore, the probability of the event A, that would be the number of outcomes in the event A divided by the number of events in the sample space S1. So that would be 1 by 2. And similarly, for the event B, the probability of the event B, that would be the number of outcomes in the event B divided by the number of outcomes in the event S, means the number of outcomes in the sample space S2. So that is, in B, it is the event 3 appears on the die. So that would be 1 by 6. And for this experiment, the name of the experiment, it is the combination of these two experiments. It means that a fair coin and an unbiased die are tossed. So in this experiment, the sample space would be the, so it would be, we can get head in the coin and 1 in the die, and head in the coin and 2 in the die, head in the coin and 3 in the die, head in the coin 4 in the die, head in the coin 5 in the die, head in the coin and 6 in the die, and tail in the coin 1 in the die, and tail in the coin and 2 in the die, tail in the coin and 3 in the die, tail in the coin and 4 in the die, tail in the coin 5 in the die, and tail in the coin and 6 in the die. So there would be 12 possible outcomes for this combined experiment. It is a combination of the experiments 1 and 2. So therefore, here we need to find the event A intersection B. A intersection B. It means that head is obtained in the coin and 3 is appearing on the die. It means it is the event that is H3 actually. So therefore, the probability of A intersection B, that is obviously the number of outcomes in the event A intersection B divided by the number of outcomes in the sample space S. So that would be 1 by 12. So therefore, here we can see that the probability of A intersection B, that is coming 1 by 12, which is also equal to 1 by 2 into 1 by 6. It means that the probability of A intersection B, that is also coming equal to the probability of A times the probability of B into the probability of B. So hence we can say, hence the events A and B are independent events. Hence the events A and B here are independent events. They are independent events. Thank you.